Okay, in this video we're going to talk about the change of base formula. This is the last property of logarithm. This formula is really useful because sometimes you want to get the approximate value of certain logarithm. For example, you want to find the value of maybe log base 4 of 25. This value is not a whole number because 4 to the any whole number power is not equal to 25. So, but we want to get some idea of how big or small that number is. So we want to get the approximation. So we try to use a calculator. But the problem is that in our calculator, we can only get the value of logarithm when the base is 10 or the number e. You know the number e, the irrational number. So these are the only two bases that we can get the approximation of. So certain these kind of logarithm we cannot just directly type it into our calculator. So for those cases, we need to change the base 4 into either 10 or e. That's why we need a change of base formula. So the way to change this one is, if you look at that formula, change log base b of m is equal to log base c. So that's the new base that you want to change to. So since we prefer that the base will be 10 so that I can type into our calculator. So I will use the base 10 as our new base. So on the top I will just write the new base, and for our new argument I'm just gonna continue with our old argument. So I'm just gonna copy this 25 as the argument of the top logarithm. For the bottom logarithm, I use the same base that I used for the top, which is 10. And then for the argument of that, the bottom logarithm, I'm going to use the old base. So that number becomes the new argument. And this number just goes to the top. So that's what this means. When you change to a new base, the argument becomes the argument of the numerator, and the base, which is b, becomes the argument of this new argument of the denominator. So let's go through some examples. This one, they say evaluate log base 81 of 27. So if I'm gonna use a calculator, I can just change that to base 10. So if I'm just using that change of base formula, I'll write log base 10. I don't have to write base 10 because that's the common logarithm. And then I'm just going to write the argument, which is 27, over log base, same base, which is 10, and so I don't have to write that. The argument, the base goes to the bottom. So it becomes 81. Base goes to the bottom. So if I'm just going to calculate that using our calculator, I'll just type in log 27, so I don't have to write 10, and then that's approximately this number, 1.431, and then I'm going to divide that by log 81, and then I'll get the approximation of 0.75. But for this specific problem, you don't really need to have a calculator. Let's assume that we don't have calculator for this problem. So we cannot even get the approximation of the common logarithm. So what I will do is, you look at 81 and 27. They have some common factor. We know 27 is 3 cubed. We know 81 is 3 to the 4th power. Because 27 times 3 is 81. Now I can, instead of changing that the new base as 10, I'm gonna change base to 3, because they have common base of 3, so maybe that will work. So log base 81 of 27 is same thing as, I'm just gonna change to base 3. Base 3 of the argument, which is 27, over log base 3 of the base becomes the argument, so it becomes 81. So now what is log base 3 of 27? Well, 3 to the third power is 27, so that value is equal to 3. And what's log base 3 of 81? Well, 3 to the fourth power is 81, so that would be just 4, which is, so that whole logarithm is equal to 3 over 4, which is same thing as 1.775. So for this specific problem, same as the try this number 1 problem, you don't really need to have the calculator. You just have to find the common base. In this case, that was 3, and then I just took the base of 3 instead. So I can have the whole number over here, whole number over here. So you can do the same thing for try this problem. So try without using the calculator, try to get that value doing this way, and then if you're not sure, you can check your answer with by changing these into common logarithm like that, and then type in the number to the calculator. For example 2, however, if you look at 5 and 36, well, 36 is like 6 squared, and 5 is just 5. There's no common base. So that means, since there's no common base, we just have to change that to the common logarithm with a base of 10. So using our formula, I'm just gonna rewrite this. Log base 5 of 36. I have top logarithm and the bottom logarithm. So the new base will be 10 because we have to use a calculator this time. So 10, I don't have to write 10 here. And then, but let me just write it so that you know that's the base. And then for our argument on the top, I'm just gonna use the old argument, which is 36. In the bottom, I just write log the new base, the same base, which is 10. And our old base becomes the new argument of the denominator, so it becomes 5. So because 10 is just a common base, common logarithm, I can just type this into our calculator and see what we have. So I'm just gonna type in log 36. That's the base 10 of 36. Just move it here. So that's approximately about 1.556. And then I'm gonna divide that by this number, which is log common logarithm of 5, and that equal to about 2.227. Maybe let's round up to the third decimal places. So that would be the approximation. So for the next try this problem 2, you will have to use a calculator because there's no such common base. So you will have to convert this to common logarithm like I did, and then calculate the approximation.